Every time you tap a screen to load a video, a file located hundreds or even thousands of miles away begins playing almost instantly. We do this so often that the process feels completely frictionless, like a bit of everyday magic. But before any piece of data can even reach the wider internet, it has to physically cross the airspace between your device and your local Wi-Fi router. That gap is an incredibly hostile environment. It is packed with physical barriers like walls and furniture, and flooded with competing invisible signals from Bluetooth devices, baby monitors, and even the radiation leaking from your microwave oven. So how does a massive, high-definition video file navigate this invisible traffic jam without losing a single pixel? To see how that actually works, we have to slow time down to a fraction of a millisecond and track a single piece of data on its journey. Your phone or laptop can't just shout a massive data request across the room in one giant continuous burst. Instead, it relies on a set of rules called the Transmission Control Protocol, or TCP/IP. The primary job of this protocol is to take your large data request and chop it up into tiny, manageable units called packets. Each packet carries a small slice of the actual payload, along with some critical shipping instructions. This includes a source IP address, a destination IP address, and a specific sequence number so it can be identified later. By converting a large, clumsy file into thousands of uniform, modular pieces, the data is prepared to survive the chaotic journey ahead. Inside your device, an antenna acts as a transducer. It takes these digital packets, which exist right now as electrical signals, and converts them into radio frequency, or RF waves, to broadcast into the air. If your device tried to send all those packets on a single radio wave, the signal would be incredibly vulnerable. It would bounce off walls, fade out, and get scrambled by the ambient wireless noise in the room. To protect the data, modern Wi-Fi relies on a mathematical engineering breakthrough called orthogonal frequency division multiplexing, or OFDM. OFDM slices the data stream into multiple closely spaced subcarriers. Being orthogonal, they overlap tightly without colliding. Because packets are distributed, multipath fading isn't fatal. If one wave bounces off a coffee table and degrades, the stream survives. The rest carry right on through. OFDM provides the mathematical armor that allows fragile digital data to navigate the physical chaos of the open air. Those surviving waves finally reach the antennas on your Wi-Fi router. The router catches them and demodulates the radio frequencies right back into electrical signals. Here, the wireless portion of the journey ends. The data is handed off from your local modem to your internet service provider, transitioning from the air into solid wires. Before the packets can leave your neighborhood, they check a directory called the Domain Name System, or DNS. This translates the human-readable website name you requested into a specific digital GPS coordinate to guide the packets. Coordinates locked, the packets fire through the internet backbone as rapid pulses of light. Looking at these exposed glass fibers, you see the actual hardware responsible for routing your data across oceans to reach a massive data center somewhere on the globe. We use terms like the cloud or wireless, but they are mostly illusions. The internet relies entirely on a massive, planetary-scale physical infrastructure of cables. Once your packets reach the server, it locates the specific video data you requested and fires it back through that exact same rigorous physical infrastructure. The data races through fiber optic lines, hits your local router, and takes one final wireless hop. Using LFDM, the router converts the video data back into radio waves to cross the chasm of your room. Your device's antenna catches the signal, and its TCP/IP stack goes to work. It reads the specific sequence numbers stamped on each packet to stitch the fragmented data back together in perfect order. This entire global round trip, translating binary into radio waves, converting it to light, traversing the planet, and reassembling the math, is completed in a matter of milliseconds. The little Wi-Fi icon at the top of your screen is a real-time indicator of a successful, microscopic global symphony of engineering, repeating its cycle thousands of times a second.